Imagine being able to store and manipulate data in your programs with just a simple name. Variables in C make this possible, transforming how we interact with memory. In this video, you'll learn how variables are declared, named, initialized, accessed, and how memory is allocated for them in C programming. Let's embark on a journey through the essentials of variables in C. We'll explore their basics, naming rules, how to initialize and use them, and finally, how memory is allocated. Variables are the foundation of data storage in C. In this topic, we'll uncover what variables are, how they work, and why they're crucial for programming. Let's start by defining a variable. In C, a variable is a named piece of memory used to store data and access it whenever required. This concept is fundamental because it allows programmers to work with data without memorizing exact memory addresses. By naming memory locations, we make our code readable and manageable. Here's how different types of variables in C are used to store various kinds of data. Integer variables store whole numbers using the int data type. Floating point variables store decimal numbers and can use float or double types. Character variables store single characters using the char data type. Here's how we declare variables in C, specifying their type and name. Line 4 declares an integer variable named age and assigns it the value 20. Line 6 declares a floating point variable named height and assigns it the value 5.7. Line 8 declares a character variable named grade and assigns it the value A. Naming variables correctly is essential for clear and error-free code. In this topic, we'll break down the rules that govern variable names in C. Here's how the rules for naming variables in C ensure clarity and prevent errors. Variable names can include letters, digits, and underscores, but nothing else. Variable names must begin with an alphabet character or an underscore, never a digit. Variable names cannot contain any white space. Variable names must not be any reserved word or keyword in C. Each variable name must be unique within the program to avoid conflicts. Initializing and using variables is where the real action happens in C programming. Let's see how values are assigned, accessed, and changed. Here's how variables in C are initialized, either at declaration or afterwards. The initial value is the first value assigned to a variable using the assignment operator. Variables can be initialized at the time of declaration, combining both steps. Variables can also be initialized after declaration, assigning a value later. Here is how we update the value of a variable in C, including using expressions. Line 5 assigns the initial value 10 to the variable number. Line 8 updates the value of number to 25. Line 11 updates number by adding 5 to its current value. Here's how variables are accessed and used in expressions throughout a C program. You can access the value stored in a variable simply by using its name. Variables can be used in expressions, substituting their stored values wherever needed. Behind every variable lies a story of memory allocation. In this topic, we'll reveal how C assigns memory to variables and why their data type matters. Here's how the distinction between declaration and definition affects memory allocation in C. Declaration tells the compiler about the variable's name and type, but doesn't allocate memory yet. Definition is when memory is actually allocated for the variable. Here's how the type of a variable influences its memory allocation and how you can check its size. The data type of a variable determines how much memory is allocated for it. The size of operator can be used to check the size of a variable in bytes. Here's how we use the size of operator to find out the memory size of a variable in C. Line 4 uses the size of operator to print the size of the integer variable num in bytes. Variables are more than just names. They are the keys to efficient and powerful programming in C. By understanding how to declare, name, initialize, use, and allocate memory for variables, you unlock the full potential of C programming. Let these principles guide your coding journey.